Hey, good morning, folks. Yeah, it's Tuesday morning, or maybe it's the afternoon when you're watching this. Buenos dias, buenos tardes. Um, I'm not sure. Hopefully you're watching it this morning in class or in fifth period. But, anyways, we're adding to our notes in section 2. So let me kind of zoom out for a second. And these were our notes, right, from yesterday. And I came around and I stamped your notebook yesterday looking for the right work. And the work that I was looking for were these 4 steps. Now, what I want to do right now is I want to zoom in on this idea. Remember how we said the absolute value is the distance that a number is from the origin. So, 5 is 5 away from the origin. -5 is also 5 away from the origin. Now, mathematically, here's how they do that. They take the opposite of the -5, right? So here's the -5. If we take the opposite of -5, it becomes a +5. And yesterday, they weren't really kind of in our book, they weren't really showing us that opposite on the left side. They were doing the opposite on the right side. So I mentioned it in my notes. I said, look, we could take the opposite of the 5x plus 1, but the book puts the negative on the right side of the equation. And with equations, it doesn't matter, right? It doesn't matter. Like if I multiply both sides by -1 or I divide by -1, nothing happens to the equality sign. It's still an equation. But with inequalities, it makes a difference when we multiply by a negative on both sides of the inequality. These were all our notes yesterday, right? So if you missed yesterday's notes, please watch that. Notice today we're going to focus on inequalities. So I'm going to highlight this guy just to hopefully really draw your attention to it. And this guy right here, this inequality sign makes a huge difference, okay? And let me show you what the book puts down for their notes. It's kind of interesting. There's still going to be 2 cases, all right? And the first one we're dealing with is that less than sign. Now, it doesn't matter if it's less than or equal to. The top row here is going to be for less than and equal to. So let me do that real quick. So like right here, this could be for less than or equal to also. And then this one down here could be for greater than or equal to. So let me point out what happens. When they do case 1, it's like if ax plus b is positive. Well, that changes nothing. You got ax plus b less than c. But if ax plus b is negative, notice how they put the negative sign right there? They didn't do that with equations. And here's why they're doing it now, because you've got to get that negative to the right side of the inequality. And when you divide by -1, it switches the inequality sign. So I'm going to show you these 2 cases over here in example, whatever it is, 5, I think. And I want you to put it down in your notes. So if you followed me on that reasoning, that's fantastic. If you didn't, and you're just like, hey, look, I'm just going to try to do whatever Nelson tells me to do, the steps, that's okay too. I don't want to, I'm not trying to shame anybody. It would be cool if you tried to understand what's happening. But if you're like, hey, I'm just trying to survive, Nelson, I got a lot going on in my life. That's okay. I understand. So here's what we're going to do. We're going to add 5 to both sides. So first step is to isolate. It's the same as step 1 in our equations. Okay, so here we go. 4x minus 8 absolute value. After we add 5 to both sides, it's going to be less than, still the same sign. The only time we switch the sign is when we multiply by a negative or divide by a negative. I'm just adding a 5 to both sides, so I get 16. Okay, so check mark. Step 1's done. I guess I gave myself a little bit too much room here. Let me move up step 2 and 3. Okay, so step 2 is to write your 2 cases down. Cases. Okay, so here come the cases. This is kind of weird with inequalities. If 4x minus 8 is a positive number, here's case number 1. If 4x minus 8 is a positive number, well, then it's just going to be less than 16. Okay, so here's case 1. All right, now case 2 is if 4x minus 8 is a negative number, then what I would need to do is I need to multiply this by -1 to take and make it a positive. That's what the absolute values are going to do. It's going to make it a positive number, right? But instead of multiplying the left side by -1, what I'm going to do is I'm going to do like 2 steps in one right here. I'm going to multiply the left side by -1, but I'm also going to divide by -1 on both sides. and that's going to flip the inequality sign. So it goes from a less than symbol to a greater than symbol. So over here in case 2, I'm going to switch this guy right here to a greater than, and I'm going to take the opposite of the right side. So let's see here. I got to put down negative 11. So in case 2, here's what I want you to make a little note of. Switch the inequality sign. The inequality sign. Okay. All right. So let's keep going. Now in step 3, it's to solve the inequalities. All right. So here comes step 3. It's solving. So let me put that right over here. Solve. All right. So here's what solving looks like. I'm going to add 8 to both sides. I think that's the same in both scenarios here. So let's just do both at the same time. And I get 24 on the right side. Wait, got to add 8 over here. Let's see, negative 8 plus 11 is negative 3. Man, if we botch one of these little arithmetic maneuvers, obviously we're going to get the wrong answer. So we got to be careful with our arithmetic. In my opinion, mathematics is not the same as just arithmetic. Arithmetic is just doing addition, subtraction, multiplication, division, like kind of the basic 4 operations. Mathematics is like, what does this mean? Where would you use this kind of stuff? And I didn't give you a scenario where you're going to use it. We are just trying to understand like why we switch the inequality sign, and then kind of the basic operations in solving an inequality. So here comes the rest of our work. Divide by 4, right? Because how do we undo 4 times x? Well, we divide by 4. That gives us a 1x. So I got 1x is less than 6. And then over here, I'm going to divide by 4 and I get x. Oh, shoot. I wanted to show a little bit of work here. So I'm dividing by 4. Okay, so here we go. Divide by 4, divide by 4. And I get x is greater than negative 3/4. Now, there's something else that's really important in these problems. We were saying all numbers less than 11. Like, we want, how should I say this? Over here, you notice this is another super important thing to pay attention to, okay? I'm going to switch to my highlighter. And what I want you to highlight is, in your notes, this word right here, and, okay? And means we want the numbers that are less than 6 and at the same time greater than negative 3/4. Okay, so I'm going to put the word and over here on these inequalities. When you have a less than symbol or a less than or equal to symbol, it's going to have the word and in between your solutions. So right in here, I'm going to put it in all caps. And now, why the heck is that important? Well, if I make a number line, okay, so let's do a little number line here. And this, by the way, is step number 4, is to write your solution down. So write the solution. And what I mean by write the solution is we are going to graph it and we're going to write it in set builder notation. So in set builder notation, it's going to look like this: x such that, okay, and we'll get to that and the rest of it in just a second. So we want the numbers. Let's see, let's put a 0 on here so we know where the point of reference is. And let's say negative 3/4 is like here, okay? So negative 3/4 is right there. And then over here, let's say we got 6 on the number line. We want all the numbers that are less than 6 and at the same time greater than negative 3/4. See, if we just had this, if we just had all the numbers less than 6, that'd be all these numbers over here. But these numbers over here are not greater than negative 3/4. So the word and means both of these things have to be happening. We want all the numbers that are less than 6 and greater than negative 3/4. So to say greater than, instead of greater than or equal to, we put an open circle. To say less than, we put an open circle. If it said less than or equal to, it would be a solid circle saying we want 6. But we don't want 6. We want all the numbers less than 6. Then you would shade everything in between because we want all these numbers. Do we want 0? Yeah, 0 is going to work. Do we want like 0.1? Yes. Do we want negative 0.1? Yes. So we're shading all of this stuff saying we want all those numbers in between. Now, how do you do this? As an inequality, you put the x in the middle and you say, I want the numbers that are greater than negative 3/4, and I want the numbers that are less than 6. This means right here, when I say this, it means and. We want the numbers that are greater than negative 3/4, and we want the ones that are less than 6. And you close it with a little curly bracket. Now, here's what's going to happen next. You and a partner are going to go to the whiteboard. You're going to try a problem from our homework. then we're going to come back and we're going to watch some more video. So thanks for watching the video.